Alright, today we're looking at solving exponential equations and inequalities. So the first thing I'm going to tell you is this is where knowing this chart, so I don't know if you remember this, it's been a while since we've used it, knowing this chart and having this paper handy is going to save you a little bit of time. You'll see why here in a minute. But it really helps to know some of these radicals and stuff and what they do and these exponents and stuff because it'll just help you, trust me. Okay? So first thing you have to do to be able to solve, and we've actually done questions like this before. We had a test over this recently. They didn't exactly look like this. They had more basic questions. Like it said 3 to the x times 3 to the 2 equals 3 to the 5th, right? And you said, oh, well, I know that I add my exponents. So that's the same thing as 3 to the x plus 2 equals 3 to the 5th. And so you knew that x had to equal 3 because these bottom numbers are the same thing. So that's basically what we're going to use to solve these exponents. Okay? So the first thing, if the big number is already the same, so these are both 3's, these are going to be your favorite questions. You get to basically ignore the big numbers and just solve your exponents. So just using, your good old algebra skills. You're going to subtract the x over here and add the 1 over here. So that gives you x equals 3. Done. Not a bad idea to plug it back in and check it and just make sure that 2 times 3 is 6 minus 1 is 5 and that 3 plus 2 is 5, so it does check. Okay? So if you notice on here though, not very many of them are already set up like that. Lots of them require you to do more work. Okay? And this is the part that's going to trick you. Okay, so I need to turn a 2 and a 4 into the same type of number. Okay, well, you know that 2 squared equals 4. Okay, but you can't just square this 2 to make it equal this 4. What you have to do instead is you have to rewrite this 4 as 2 squared. Okay, so that 4 is 2 squared, but you still have this power of x plus 2 out there. Do you remember what you do with your exponents when you have a power to a power? You multiply. Okay, so this 2 that I just had to add here because I rewrote 4 as 2 squared is going to multiply through this whole function you had up here, and now we can solve because these 2's are the same. I can ignore them. That's 3x equals 2 times x plus 2. When I distribute that 2, I'm going to come over here. That's 3x equals 2x plus 4. I solve this by subtracting the 2x. That gives me x equals 4. Okay. If you're not sure, you should definitely check it. If I plug in 4, that's 2 to the 12th power. If I plug in here 4 plus 2 is 6. But remember, 4 is already 2 squared, so 2 times 6 is also 12. Okay? So again, this next one. They're not the same, but I can rewrite 1/9. 1/9 is the same thing. Again, if you're not sure, look back at this paper. I need 1/9 to be 3 to some power. Okay, well, 1/9 is actually, if you keep looking on here, 3 to the, I don't even know why I can't find it right now, 3 to the negative second power. Oh, because it's on the front, that's why. Here we go. 1/9 is actually 3 to the negative second power. So I can rewrite this 1/9 as 3 to the negative 2. Now these have the same number, and I can just solve what's left. 2x minus 1 equals negative 2. I add the 1. 2x equals negative 1. X equals negative 1/2. Again, you could totally check this, especially if it's a number like negative 1/2. 2 times negative 1/2 is negative 1. Negative 1 minus 1 is negative 2. 3 to the negative second power is 1/9. Okay, so not a bad idea to check it. Okay, sometimes you have to change both of them. For example, I have no power that I can go straight from a 4 to an 8. Okay, you can't do unless you use a fraction, which actually is an option, but I don't recommend it. However, I can turn both of these into 2 to a power. So 4 is 2 squared, 8 is 2 cubed. Again, you're going to have to multiply that by the rest of the power that's there. Again, you can ignore your 2's now and solve what's left. 2 times x plus 1 equals 3 times 2x plus 3. I'm not going to finish solving that because you should be able to do the algebra part of that. The hardest part is just setting these up. Okay? So very similar thing on the next one. You have an 8 and a 16. Well, technically a 1 over 16. What number can you turn both of those into? 2's. So 8 is actually 2 cubed. 1 over 16 is 2 to the negative 4th. Again, you're going to have to multiply this right here, but you should be able to solve what's left. What about 25 and 125? Those are both 5's. So you can rewrite 25 as 5 squared. You can rewrite 125 as 5 cubed. And again, you would solve what's left. Mark out the 5's and solve what's left. Okay. 9 and 27 can both be written as 3's. This is 3 squared. This is 3 cubed. You can solve for your exponents now. 36 and 216. You should know this one. 36 is 6 squared. And 216 is 6 cubed. Okay. Last one, 64 and 16. There are actually two answer choices here. You can either say that this is 4 to the negative 3 and 4 squared. Solve that one. Or maybe you knew that this was actually 2. 2 to the negative 6 and 2 to the 4th. Either one of these would get you the correct answer. Okay? Good deal. So looking at writing an exponential function, okay? So first of all, an exponential function, you might need to think back a little bit about when we graphed the other day. They're usually in the form y equals some number times b to the x power. Okay, that's usually just the way that it's kind of written. Okay? So the first thing you need to do is figure out what that sum number is. Okay? Well, the easiest way to do that is they've actually kind of given it to you because they tell you what the point of 0 is. And if you remember when we graphed the other day, looking back at this, our 0 point, so like this one, is at 0.3. This one is at 0.1/3. This one's at 0.25, 0.2. That one doesn't count because it's been moved. 0 is always going to give you this number in front, the a point. Because no matter what b is, when you do b to the 0 power, well, let me just write this down. We know we're looking for y equals a times b to the x. Okay? I know that y is 4 when b, or when x is 0. Well, anything to the 0 power equals just 1, so I know that a is 4. Okay. To finish this, you can do a couple things. I usually just plug my points in. So I now know that a is 4. For this next one, it says 36 equals 4 times b to the second power. Well, if I divide by 4, 36 divided by 4 is 9. So this says that's what you need to do first, divide by 4. 9 equals b squared, so b has to equal what? 3. Good. So this tells me my equation, y equals 4 times, you can put times 3 to the x, or usually it's written like this. Either one. Okay. So same thing on the next one. You should already know that this is your a. Y equals 6 times some number to the x power. Again, plug in your x and y. So 81 equals 6 times b to the first power. Well, 81 divided by 6 is not a reasonable number, but that's okay. I can reduce it just a little bit, okay? B to the first equals, both of those are divisible by 3, so 27 over 2. Good news is that's b to the first, so that is b. So your equation here, y equals 6 times 27 over 2 to the x power. Same thing on the next one, okay? So I know already y equals 5b to the x. If I plug in 320 equals 5b to the 6th power, 320 divided by 5 is 64. B equals 2. So your equation y equals 5, 2 to the x power. And notice I wrote this one with the x on the inside, this one with x on the outside. Actually, either one of those is fine. It's a fine answer. Okay. Let's get to maybe a complicated one. I'm guessing you're probably not a fan of the fractions. I guess I'll do 13 too. So I know y equals 2 times b to the x. So 486 equals 2 times b to the 5th power. What a terrible number. So 486 divided by 2 is 243 equals b to the 5th power. So maybe you don't know that one off the top of your head. That is okay. I forgive you if you need to use a calculator on this one. But that actually tells me that b is 3. I can either do 243 to the 1/5 power or take the 5th root of 243 to figure that out. You can also guess and check. So y equals 2 times 3 to the x power. On this one, you know y equals 8 times b to the x. 27 over 8 equals 8 times b to the 3rd power. Well, the first thing you're going to do is divide by 8. What is 27 over 8 divided by 8? Well, you should know, maybe you don't, that that's the same thing as 27 over 8 times 8, or 64. So if b cubed equals 64, equals 27 over 64, then b is going to equal 3 over 4. So again, your equation equals 8, 3 over 4 to the x power. Okay. I don't think I'm going to go any further on that. I'm just going to go ahead and flip it over to the back. Let me know if you have some questions. On the back, the only difference is that these are inequalities, so these are exactly like the front. Okay, so maybe I'll just work a couple here to kind of get you started. Like, what about one of these that has all these terrible, terrible fractions? I don't like that one. Let's actually do, so this you should reduce this. I don't know, let's do an easier one first. Let's do this one right here. So 81 and 9. Again, two ways you can do that. You can either turn them both into 3s, or you can turn them both into 9s. I'm going to say obviously 9s is easier because one of them's already a 9. That one would stay. 1 over 81 is 9 to the negative 2nd power. After that, again, you can just drop those and solve the equation you have left. 2x minus 4. I add the 4. 2 is less than 2x divided by 2. That gives me 1 is less than x, or x is greater than 1. I personally like it that way a little better. Okay. Same thing, like I said, if we were going to do this one right here, 7 over 343 is a stupid question because this actually reduces to be 1 over 49. So you should definitely, if you get a weird number like that, you should definitely check that out first. Because now, look at them, they're already the same. I just have to solve my exponents. Okay? Remember when you're solving here, I personally recommend that you move it in a way that keeps the x term positive. I'm going to intentionally do this time. So that's a negative x is greater than or equal to 4. Remember when you divide by that negative, you have to do what? X is less than or equal to negative 4. Okay, same thing with this one. 9 over 27 actually does reduce. Those are both divisible by 9. That's 1/3. This is 3. So that would actually be a better idea to do that first, but you don't even have to. Well, maybe you do. You can also tell that these are just flipped. So what can you do to flip something? Well, I could just rewrite this one as 9 over 27 to the negative 1st power. And then you have this x plus 6, this negative x plus 6 already there. So you could do that too. either way, you're going to have to do that. So 6x minus 1 is greater than or equal to, when I distribute my negative 1, that's a positive x minus 6. Subtract the x, add the 1. That gives me 5x is greater than or equal to negative 5. X is greater than or equal to negative 1. Okay, I think you probably got that.